Okay, hello. So basically आज हम लोग start करेंगे ग्राफ ग्राफ में बेसिकली बाइनरी ट्री उतना कुछ टफ नहीं है बट लेट्स सी। तो फर्स्ट देखता हूँ चैनल का स्ट्रीम स्टार्ट हुआ कि नहीं। ओके। हम्म सो द पॉइंट है कि आज हम लोग स्टार्ट करने वाले हैं बाइनरी ट्री। और इसमें भी इजी कॉन्सेप्ट आज के लिए क्योंकि मतलब ये तो मैंने पहले ही देख लिया था। विल गो विद दिस। इट्स इजी प्रियोर ट्रैवर्सल। आई होप इट्स नॉट टफ प्लीज। ओके इट्स इजी नॉट टफ नॉट टफ। Ah, so they want us to do a Preorder Traversal on this one. What if I call a function? रिटर्न क्या करना है? वेक्टर इंट आंसर रिटर्न करना है ना? रिटर्न करेगा आंसर को। सॉल्व रूट को कॉल करता हूँ। रूट इज अ ट्री नोड। आंसर ओके। और इस फंक्शन का वॉइड सॉल्व ट्री नोड रूट वेक्टर int plus answer. hmm So I'll be addressing it, and if root, ये root है ना, so how will we get a null? Okay, if root is equals to null, return. Else, what do you do? Uh, it's a, it's what order? It's pre-order. So how do we do a pre-order travel? So suppose this is the thing. How do you pre-order 1, 2, 4? Then you go to 5, 6. Okay, so basically you will first store the answer. So answer dot pushback root. What does root have? Root have a val. Root have left it in a val. So val, and then we'll just call the function for root left, and we'll call the function for right. That's all, I guess. I mean, this one is easy one. That's why I'm probably able to solve this. Oh my god, there is still something wrong. Okay, probably I haven't written null. Please, let's not embarrass myself with this easy question, and I'm embarrassing myself still because I'm not calling the function parameters correct. Okay, now it should work. Please, it should work. Yeah, it is an easy one. I can do it. I can do it. Come on. Okay, this one done. It's called Inorder Traversal binary array. Again, this one is also easy. That is why. So it is the same parameter as last one. So we'll be just copying the answer. So let's see. We'll just be doing this. No, my bad, my bad. So we'll just be pasting this, and then we are just gonna make sure that this comes in the center, and it is vector int answer, and we are gonna call solve function on root and answer and return answer. See, same parameters, the middle, because that is how it works, right? So yeah, see, it's easy. That's why I can solve it. Two questions. Okay, and now it is gonna be a Postorder Traversal. Come on, bro. I know it is not gonna be tough, but fine. It is a learning curve. Vector int answer solve function of root and answer return answer, and this time so see how it is, because we had see we're traverse and returning back, and while returning back we are gonna add it to output because of that. In case, I mean, if anyone knows it, obviously it is a reason. So yeah, three questions, let's go. Okay, why am I getting easy ones? Come on. Okay, let's see what is this one. Probably this one is gonna take me time, a lot of time basically. So first, let's see. The answer they want is in the form of vector. Okay, let me create that and return that. Now what they want is they want me to be traversing in the form of a level order, right? So this is a route. They want me to traverse in that route, and they want to go in this order. Oh yeah, I know this one. This one is probably the form of queue, right? Okay. Wait, we want a queue of what? They want a int. So, hmm, they just want a queue of int. Let's make a dequeue and and that queue will be pushing back root.data. No. Let's make a queue of tree node, and that will be pushing root. And while queue is not empty, do we have not empty? Please tell me we don't have. We have, my bad. So we'll be taking a tree node of, what do we now need? Temp, and we'll be getting dg dot pop. Do we have? Do we have? You know what? I am bad with queues, so let me just see queue in C++ operations. I'm not cheating. I'm just trying to get data. So queue में करते क्या क्या हैं? We'll be having a queue. I just need a normal queue. This is the queue. Okay, queue will have a push function. Obviously, we have a front, we have back, and we have pop. Okay, so we want a front, and then we'll be popping it. Okay, if temp dot left is not equals to null, that means it has a left part. So we'll be pushing temp left. If temp dot right not equals to null, we'll be pushing the right part also. So basically, if these two left and right exist, just push it. Along with that, okay, no. We are doing something wrong here. Okay, we push these two, and these two we're pushing this. So how come it's a leveler traversal? Because we want a size. We want a size of it. So int is equals to size, and we want a for loop running for the size. Because how do we group these values if not we don't run a for loop? Okay, and we want to store it in the form of temp answer. You know what? Temp answer, because we already have a temp variable. Now what we want is in every parameters we are gonna see. We are gonna suppose this has only size 1, so we are gonna run the loop one time. We're gonna get the left, we're gonna get the right, we're gonna push the left, we're gonna push the right, as well as in the temp answer we're gonna push the value of temp data. Is it a data? Is it a val? What do we have? Val. We're gonna push val. Now, at the final step, we're gonna push in the answer temp answer. Let's see if this works. Probably this should work in case I'm not doing something as wrong as usual. We don't have a pushback. We have we have a we don't have a push. We have just push. Do we have just push? We don't have a pushback. Okay, a queue just has push. Okay. Now, when accessing null pointers, so basically, how come is it is not null? We push it. The value. If it is not null, so how come a null came in the first place? Wait, oh wait. If the root is null, just return null. Okay, my bad. I never took the exception. So if root is null, just return the answer. I think this should do it, but let me see. Okay, this works. Some basic concepts of graph I can understand a little better, that's why. Okay, is it the same question? It is the same question. You just want me in an iterative manner? No, okay, wait. They want me iterative pre-order, iterative. I mean, I know they just use a stack. Post-order traversal in two stacks. So what do you mean post-order traversal two stack? Iterative traversal. Let me see. Basically, they want me to use a stack to do a iterative traversal. Oh yeah, I know this. You check the levels. Post-order traversal using two stack. Let me see how do you do it. So it is a stack one to traverse the binary tree and stack to store the reverse of the post-order traversal. So basically, they have two stacks. When the stack is not empty, you get the value at the top, you pop it, you push it in the second value. If it is not left, it is not right, you push the value. Ah, okay, makes sense. Preorder post-order traversal in one single traversal. I mean, I know this one. So, okay, how far have we came into the stream? I mean, I don't know. I haven't. I am not keeping the check, but it is probably 13 minutes. Okay, the easy parts are done. Let's just check this one, and we'll be done for the day. Okay, lead code says it's a easy one, and basically they just want me to tell the maximum depth. Can I do a just breadth for search and we'll just be counting for every values? I think I can do that. Okay, suppose we have a count variable as 0, and if root is equals to null, let me just not forget the value. What if just a null will return 0? Isn't that right? Yeah. So we'll be using a queue of tree node and tree node star, my bad, and we'll be naming it as queue. We are gonna push inside the queue root, and while queue is not empty, we have not empty function, right? Yeah, I use something like that. So we're gonna get a size, queue dot size, and for int I is equal to 0, I less than size, I plus plus. We ran till the value size, and whatever we're gonna do is basically for every step we're gonna get a value called temp, and we're gonna do we need a oh wait, we can do a DFS also, but nah, BFS is fine. I mean, how many traversals? We have a traversals of 20 per 4, so it will work. So basically we're gonna get this value by pushing from the front, and we are gonna pop the value, and if the temp dot left is not equals to null, basically if it is not null, then temp dot pushback. I mean, sorry. Oh, wait, we're putting in the queue, right? Queue dot push temp dot left. If temp dot right not equals to null, then just push inside temp dot right. Okay, that works. And we'll just, for every iteration, we'll be just increasing the value of count. And wait a second, the count increases, right? Yeah. Wait. We need a depth. We need a depth. The value of depth. Is it the height? Uh, maximum depth. I don't think this will work. Will this work? I know something will be wrong, but you know what? It's a learning curve. So it's a learning curve. Yeah, I know. I have done the syntax wrong. Just give me a second. Okay. It either may be a question of height or I'm doing it wrong. Oh, no. I know it is wrong. I know it is wrong. No. I know it will be wrong. It will be. Oh, what? Okay. So technically, if you just keep increasing the value of count and do a BFS, it will tell you the maximum depth. Well, I was wrong. Fair enough. My bad. Okay, from this we'll be checking in the next stream. Well, this is a very short stream, I guess. It worked. We solved like what, 12 and 113 here. A lot of progress, lot to more tries. I don't know, strings. Probably hard problems. Yeah, Rabin carp algorithm. Gonna be tough. Fine. For the future. DP 55. Good, I wanna learn it. Graphs, I'll learn it. Binary search tree, BST. Okay. See you in the next stream. Let's go. Best of luck to all of you guys.